Hey guys, welcome to part 1 of the AQA Summer 2017 paper 2H. So it's the first of the two calculator papers. So the first thing I'm going to say is make sure you use your calculator for absolutely everything. Because it's going to save us time, it's also going to save us brain power. So probably going to do this in about 3 parts. We've got some big questions, so they're going to take a lot of time. A link to the paper will be in the description of the video, so download it, have a go yourself first, or stop and start the video and play along with me. My voice probably isn't going to love it. At the moment I'm making about 3 of these videos a day and then teaching, so it's quite taxing on the old voice. So if it's breaking at all, I do apologise, but let's not make a big deal out of it. So let's get cracking. Okay, question 1. Circle the value that is closest to 39/800ths. So if we plonk that in our calculator, it will tell us that that is equal to 0.04875. Now the closest to these 4 numbers is 0.049. So that's our guide for question 1. Question 2. Circle the area that is equivalent to 36 millimeters squared. So to go from square millimeters to square centimeters, we divide by 100. So 36 divided by 100 is 0.36. So our answer for this one is 0.36 centimeters squared. Now I know that can be quite confusing, so let's have a look at another way of doing it. Let's get ourselves a shape that has an area of 36 millimeters squared. So 36 is a square number, so I'm going to use a square here. So that's going to have sides 6 millimeters times 6 millimeters. Now if we convert millimeters into centimeters, then we've got 0.6 centimeters times 0.6 centimeters. So we're then doing, in terms of centimeters, 0.6 times 0.6. If you plonk that into your calculator, that will give you 0.36. So again, our answer is 0.36 centimeters. Okay, question 3. So A is the point 212 and B is the point 82. We want to find the midpoint of AB. So to find coordinate midpoints, you take the average of your 2 sets of coordinates. So our x coordinate here is going to be 2 plus 8 divided by 2. 2 plus 8 is 10 divided by 2 is 5. So our x coordinate is 5. Our y coordinate is going to be 12 plus 2 divided by 2. 12 plus 2 is 14 divided by 2 is 7. So our coordinates of the midpoint are 5, 7. So that's our guy. Okay, question 4. So here we have a sequence of numbers, 90, 82, etc. We're asked to circle the nth term for the sequence. So given that we've got a multiple choice question here, we know that one of these is our answer. So what we could do is substitute a value in to each one for n and see which one works. If more than one of them work, then we'll substitute in another value for n. So when n is equal to 1, then we're dealing with the first term. So we're looking at out of these four for which one gives us an answer of 90. Okay, so n minus 8 would be 1 minus 8. That's minus 7. So that's definitely not our guy. 98 minus 8 times 1 is 98 minus 8. So that gives us 90. So that's a contender. Then we've got 8n plus 82, which is 8 plus 82, which is also 90. So that's also a contender. And then we got this chap on the end, 8n minus 98. That would give us 8 minus 98. So that would give us minus 90. So that is not a contender. So now we've got these two guys in the middle. So we could substitute in, say, n equals 2 and see for which one we get 82. But if we look at our sequence, it's going down. So that means our n term is negative. So this is our guy, this guy is not. So that's our answer. Now, it's also good practice to go over how to work out an nth term, so I'm also going to do it that way too. So, first of all, we need to work out what our difference is. How are we going from term to term? We're taking away 8, so that tells us our sequence. Something to do with minus 8n. If we then cover up the n, in that we're setting n equal to 1, so then we're asking ourselves, how do we get from minus 8 up to 90? We add 98. So minus 8n add 98 is exactly the same as 98 minus 8n. Jobs are good. Okay, question 5. So here we have some combination questions. So a code to a log is 4 digits long. Each digit is between 0 and 9. So the first 3 digits here are 5, 4, 1. Amy knows the last digit is an odd number, but not 7. She chooses an odd number at random. What is the probability she chooses the correct number? So, how many odd numbers are there? There's one. Sorry, how many odd digits are there? There's 1, 3, 5, 7, 9. We know it's not 7. So there's 4 possible ones it could be. So the probability she chooses it correctly is 1 out of 4. Jobs are good. Okay, and then part B. So the 4-digit code is changed to an even number. The first digit is 3. How many possible numbers could the code be? So there's a couple of ways we can think about this. We know the first digit is 3. So all possible combinations are between 3,000 and 3,999. Now that gives us 1,000 possible combinations. So half of those are going to be odd. So what's 1,000 divided by 2? 1,000 divided by 2 is 500. So our answer is 500. Another way of thinking about it is to make the number even, it's only the last digit that we care about. So the first of the 3 digits could be 10 possible things. The second of the 3 digits could be 10 possible things. But then the last one could only be 2, 4, 6, 8 or 0. So the last digit only has 5 possibilities. So 10 times 10 times 5 again gives us 500. 500 is our guy. Okay, question 6a. So here we want to complete the table for values of y using this quadratic. So use your calculator. Just be very careful when you do use your calculator. So say we're doing -2. To put in -2 squared, don't put it in as -2 squared like that, because that will give you -4. So what your calculator is doing there, it's squaring 2 first and then making it negative. So that is wrong. You want to put it in as -2 with brackets around it with a square on it, and that will give you +4. Okay, so let's put these values in them. So -2 squared is +4, -2 is add 2, so that's 6, -2 at the end, gives us a value of +4, when x is -1, -1 squared is +1, -1 is add 1, so 1 plus 1 is 2, -2 is 0, and then our last one, when x is 2, 2 squared is 4, -2 is 2, and then -2 again gives us 0. So those are our coordinates. Now we need to plot them on the graph below. So remember, your x values are your across, and your y values are your up or down values. So the graph is going to look something like this. And I know what you're thinking, that is the most beautiful graph you've ever seen. Freehanding on a tablet is really not that easy, but it will look something like that. Okay, and then the next bit of the question just asks us to write down the x coordinate of the turning point of the graph. So that is this point here, which happens at x equals 1/2. Jobs are good one for 6. Okay, question 7. Use trigonometry to work out the length x. So it's nice here they're actually telling us exactly what they want us to do. So it's SOHCAHTOA. So if we're dealing with this angle of 72 down here, side x is the opposite. The 8 is the hypotenuse. So if we go to SOHCAHTOA, work out which function we need. So, is it SOH? Yes it is, because we have O and H. So tells us sine theta is opposite, divided by hypotenuse. So here, sine 72 equals x over 8. So x is equal to, multiplied by the 8, we get 8 sine 72, which, plonk it in your calculator, it's going to give us an answer of 7.6 centimetres. Jobs are good for number 7. Question 8. So here we have a distance time graph that we need to draw. So Lily goes on a journey. For the first 30 minutes, she travels at 40 miles per hour. Then she stops for 15 minutes. She then completes her journey at an average speed of 60 miles per hour. The whole journey time is 60 minutes or 1 hour. So what we want to do is draw that on a distance time graph. So what we're going to need to do is work out what distance she goes in each part of her journey. So let's call the different parts 1, 2 and 3, and let's work out her distances for each part. So stage 1 of the journey, for 30 minutes she travels at 40 miles per hour. So to work out the distance, distance is speed times time. So 40 miles per hour times half an hour is 20 miles. For stage 2, she stops completely, so she's not going to go anywhere. So up to there, the first part of the journey was 30 minutes. The next part of the journey was 15 minutes. So we're told she completes her journey at an average speed of 60 miles per hour, and the whole journey takes 1 hour. Now in stages 1 and 2, 45 minutes has passed, so that means that there's 15 minutes left for stage 3. So 15 minutes is 1/4 of an hour. She travels at 60 miles per hour in the third stage, so 1/4 of 60 is 15 miles. So now we know our distances, we can plot these on the graph below. Okay, so stage 1 is going to look like this. So we know after 30 minutes she has travelled 20 miles. So we plot the point 30, 20 and then draw a line from the origin to this point. Here's a horizontal line across to 45 minutes because she's not going anywhere. Then our final stage looks like this. So in the final 15 minutes, she went another 15 miles. So this point here has coordinates 60, 35. So on the whole, our distance time diagram looks like that. And then the final part of the question asks us to write down her average speed for the whole journey. Well, she's gone 35 miles in 1 hour, so her speed is 35 miles per hour. Job's a good one. Okay, question 9. So these questions seem quite common these days. So we've got a bit of probability, a bit of algebra, and a table. So the good news is these aren't really that hard. We have to use the probability to get a number and then set up an equation using the algebra. So the table shows information about some CDs. So we've got the number of CDs and the type. So we've got 2 rock, X pop, and 2x plus 5 jazz. Now we're told the probability of picking a rock CD is 1/20. And we want to work out the probability of picking a jazz. So the probability of 1/20 tells us that rock makes up 1/20 of the total number of CDs. So in other words, the total divided by 20 is equal to 2. Now if we multiply both sides of that by 20, we work out the total number of CDs is 40. So 2 times 20 is 40. So now altogether, we know then there are 40 CDs. So we know if there are 2 rock CDs, and pop and jazz make up 40, take away 2, which is 38. So in terms of algebra then, we know that pop add jazz, so x add 2x add 5, we know that that is equal to 38. If we simplify that and solve it, x plus 2x is 3x, so we get 3x plus 5 is 38. Take away 5, 3x is equal to 33, and then divide by 3, we get x is equal to 11. So now that we know what x is, we can work out how many pop and jazz CDs there are. Well, there's x pop, so there's 11 pop, and then 2x add 5 jazz. 2 times 11 is 22, add 5 is 27. Now we want the probability of picking a jazz CD, so that's the number of jazz out of the total number of CDs. 27 out of 40. Jobs are good. Question 10. So you're going to want your calculator for this one, I reckon. So the pie chart shows information about voters in an election. So we've got men and women in the pie chart. We're told 3,360 more women voted than men. So that is important. And we want to work out how many people voted in total. So let's have a closer look at our pie chart. 110 degrees represents the males. So what angle represents the females? So angles around a point add up to 360. So if we do 360, take away 110, we get 250 degrees for the women. So the question tells us 3,360 more women voted. So if we work out how many more degrees represent the women, we know how many degrees is going to represent 3,360 people. So 250 take away 110 gives us 140 degrees. So the women have 140 degrees more in the pie chart than the men. So that tells us 140 degrees represents 3,360 people. So what we now need to do with this information is work out how many people are represented by the whole 360 degrees. Okay, so to do that, first we're going to work out how many people is represented by 10 degrees. So I'm going to divide both sides of this by 14. So we get 10 degrees represents 240 people. Now there are 36 lots of 10 in 360. So we now want to do 36 times 240. And that will give us 8,640 people. Jobs are good. Question 11, we want to write these three numbers in decreasing order. So that means the biggest first down to the smallest. So we got 9,563, 9.56 times 10 to the power of 3, and also 9.56 times 3 to the power of 10. Now this guy is by far going to be the largest. That is 9.56 multiplied by 3 10 times. So 9.56 times 3 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 and times 3 again. So that is going to be monumentally huge. So that is our biggest. Now with these next two, it's going to be a good idea to write 9.56 times 10 to the power of 3 as a normal number. So what's going to happen with that guy? The decimal is going to move 3 places to the right. So that's going to be 9,560, which is smaller than 9,563. So 9,563 is the middle, and then we've got 9.56 times 10 to the power of 3. Job's a good one. Question 12. So this is going to be the last bit of fun for part 1. Be sure to check out the rest of the paper in parts 2 and 3. So here we've got some lines inside of a circle, and we were asked which one of them is a diameter. So for this, we need to know one of our circle theorems, and that is that when two chords meet on a circumference off of the ends of a diameter, they meet at right angles. So we need to find a right angle here. So in this triangle ACD, we've got an angle of 10 and an angle of 80. So that means the third angle has to be 90 degrees. So our diameter is line AD. So let's put a circle around it, why not? Okay guys, so that's it for part 1. See you in the next part.